Number 5, I see a linear equation. It looks like C is the dollars that an electrician charges, and H is the number of hours they work. There's 2 people they're doing work for. We have Miss Sanchez and Mr. Rowland, and they each hired the electrician. The electrician worked 2 hours longer on Miss Sanchez than Mr. Rowland's. So for these ones, you could figure out just via slope, but just in case, if we know that they worked 2 hours longer for Miss Sanchez, I could just do 2 hours for Miss Sanchez, 0 for Mr. Rowland. I put 0 in for this. It's going to cost $125 for the electrician to show up. And then 2 in for this, it's going to be $150 plus $125. So technically it's going to cost, $150 more for the 2 extra hours. So it's just going to be C here. Number 6, I see a circle and we're dealing with arc lengths and angles. So anytime we're dealing with these two, I want to make a proportion. Our arc length is 5 pi. Our angle is 100 degrees. So that's going to be our starting proportion. 100 is equal to or represents 5 pi. And there's multiple ways you can set up your denominator. You could say, okay, well, what if we have our total 360 degrees, which would also be equal to our total circumference? But we can do a little bit of a shortcut here. They want to know the arc length of ABC. So technically, I don't have to solve for the entire circle. I just want to solve for the rest of it. So if this angle right here is 100, I could subtract it from 360, and I could say the rest of that angle is 260 degrees. All I need to solve for is what the rest of the arc length is, right? So we can do some reducing here, get rid of a 0, divide by 2. So I get 5 over 13 is equal to 5 pi over x. I can divide both sides by 5, and that makes this 1. That makes this 1, and finally I cross multiply, and I get x. Well, move it up a little bit. I get x is equal to 13 pi, or b here. Number 8, I see a function, and I see no value of x satisfies the equation. That sounds a whole lot like no solution. Remember, there's only 2 no solution problems. We have linear no solution and quadratic. This looks like a linear equation because all of my x's are to the power of 1. So anytime I get a no solution linear problem, I just put everything in slope-intercept form and set my slopes equal. So we kind of treat this like equation 1, and I treat this like equation 2. For equation 2, we're going to have to do some, distributing and combine like terms. I would get 3x plus 15 plus 5x minus 5. So that's going to get 8x plus 10. So that would be equation 2. Equation 1 was already done. Our slope from equation 1 is going to be 2a. So again, because there's no solution, my 2 lines have to be parallel to each other. So I would say 2a from line 1 is going to be equal to my slope from line 2, which is just going to be 8. And my a would have to be 4 for these to have the same slope and therefore be parallel to each other. Number 9, I see a system of 3 equations, pretty unique. Usually our systems are 2 equations. And they want to know how many solutions the system has. Well, remember, the system is all 3 equations. So a solution is only going to be when all 3 of my equations intersect, because that xy would represent a solution to all 3 equations. So this one's only 2, this one's only 2, this is all 3 lines intersecting, so this is going to be one solution to all 3 equations. Number 10, I see a factored form and an expanded form. And it's a little bit of a hint from the SAT makers. They like for you to expand your factored form and then set your x terms according to their exponent equal to the expanded form. So we'll kind of demonstrate how that happens. I start with foiling through. So we get 5a x to the third, and then minus ab x squared, and finally up top, plus 4ax. And then on the bottom, let's change colors. I see, and again, I'm going to organize this according to my exponent. So it's going to be plus 15x squared. And then minus 3bx. And finally, plus 12. Okay. And then now I want to compare according to my exponents. So it's nice, my constants cancel out. And we'll start with our x to the third. So therefore, 5a x to the third should be equal to 20x to the third. So we can divide both sides by x to the third. Oops. Get rid of this, get rid of that. And then it looks like our a is just going to be equal to 4 here. And then we kind of have a decision to make here. I can do either my x squared terms, because they both have a and b, or I can do my x terms. So I think the x terms look a little bit easier, and let's kind of demonstrate what that would look like. So I'm saying all of my x squareds on one side are equal to all of my x terms on one side are equal to all of my x terms on the other. So I'll say 4ax minus 3bx is equal to negative 2x. So again, I've just grouped my x terms on one side, grouped my x term on the other side, just like we did with the x to the third, and I make an equation. And just like last time, I divide by x, get rid of that, and then we plug in 4 for a. So this actually turns into 16 minus 3b is equal to negative 2. I can do this. We can minus 16 from both sides, minus 16, and we'll kind of write it up here. So now I get negative 3b is equal to negative 18. Divide both sides by negative 3, and I should get b is equal to positive 6. Finally, they want the value of a times b, so I just do 6 times 4, and I get positive 24 here. Number 11, if I ever see these x functions where they're asking for solutions or an x that satisfies the equation, I'm always opening up Desmos, and I'm putting my function in there. X divided by x minus 3 is equal to 2x divided by 2. And these vertical lines you see are always going to represent your x solutions. So sometimes they don't give you dots. That's fine. We can zoom in enough, and I can see that my two solutions here should be 0 and 4. And we had Desmos here. And it looks like that's just going to be b here. That's all. Number 12, 2 ways to solve this, by hand and on Desmos. By hand, I notice I have 2 terms up above, and all my answers are 1 term, so I need to combine them. To do that, I know that 5 is over 1, and I need to get equal denominators. So I can multiply my left side by my right's denominator, which is just 1, and then my right side by my left's denominator, which is 2x plus 1. But I need to do it to top and bottom, so my number stays the same. So 2x plus 1 times 2x plus 1. Down below, I get 10x plus 5 when I distribute this. My denominator stays as 2x plus 1, and then my left side stayed the same because it was only multiplied by 1. Now that they have the same denominator, I can just go ahead and combine these, and I should get plus the 1 to the 5, so 10x plus 6 over 2x plus 1. So it's not too bad to do by hand. I would probably do this one by hand, but if you wanted to do it in Desmos, let's pull that up. Again, all you have to do for these expressions are equivalent problems. You type in your first expression, and you should see a function appear, so 1 over 2x plus 1 plus 5. So I have a line here. If I zoom out, I can see it better like this. And then all you have to do is type in your answers. We know it's D, so I'll just type in like C and then D. So if I type in C, 10x plus 5, whenever you're dividing plural, you have to put a parenthesis here, divide, 2x plus 1. I see that I have a different graph, and then I just match it to answer what's in D. So I would just change this to a 6, and you can see that they're overlapping. If you want to double check, just unhighlight this color, and that's how you would do it in Desmos. Just see which one matches. It's going to be D either way. Number 18, translations. I see that we have our original graph here, f of x, and they mention this function g that's not shown here. So in these ones where we start with f of x and they translate to f of g, we always have to figure out what our answer is in f of x first, then we can translate it. So they tell us that g of x is f of x plus 6, and they specify that they want the maximum value of g. So we start back at f of x, and you ask yourselves, well, what's our maximum value? Your maximum value is always addressing the y. So I just think in terms of horizontal lines, what is the highest value my f of x can reach? And it's going to be positive 2 here. So you would say your maximum value of f of x is 2. And they're saying the maximum value of g of x, which is just f of x plus 6. So it just turns into 2 plus 6, and our max value of g of x is going to be 8 here. Number 19. You got to remember your SOHCAHTOA rules. I see a right triangle, so we go ahead and draw that. And we label it P, Q, and R. And they tell us that if sine of R is 4 over 5, so remember that sine, so, opposite over hypotenuse. So we go sine of R is going to be 4 over 5. They want to know what the value of tan of P is. So we want to remember with tan, it's going to be opposite over adjacent. Well, we don't have our opposite right now, but we want to remember one of the most popular triangles, and that is your 3, 4, 5 triangle. So just remembering that, not only 3, 4, 5s, but multiples of 3, 4, 5. That means if you had a triangle that was like 6 and 8, you would know your other side is 10, etc. But finally, tan of P is just going to be opposite over adjacent, or 3 over 4. Number 20, I see we have a function f shown, and we also have a function g that is perpendicular to the graph of f. So before I even read the rest of this, I need to get my slope of f so I can figure out what's perpendicular to it. Just remember your slope is your change in y over your change in x. So it looks like we lost 2, so negative 2 in my y. We gained 1 in the x, so positive 1. So if my slope of f is negative 2 over 1, remember for perpendicular, you have to change your sign, change your fraction. So this should change to positive 1/2. So I start my equation for g now. I know that g is going to be equal to 1/2 x plus b. But remember, they're going to have to give us a point or something to figure out what our y-intercept is. They do. They tell us that is not only perpendicular to f, but it also passes through the point 1, 3. That's an xy point, so I can plug that in for this. I can say when my g or my y is 3, and then I plug in for my x a 1, what's going to have to be b to make it equal to the other side. And it looks like 1/2, I'm going to need an extra 2.5 to get up to 3. So my b is just going to be equal to 2.5 here.